Good morning students, I hope you all are fine. Already we have discussed fourth lesson, electromagnetic induction and alternating current. Today we are going to discuss about Fleming's right hand rule. In our previous chapter, magnetic effect of electric current, we discussed Fleming left hand rule. I will recall later Fleming left hand rule. First we will discuss Fleming's right hand rule. What is that Fleming right hand rule indicates means we will take in our right hand, stitch the three fingers in our right hand. See that I will take my right hand, stitch my three fingers. What are the three fingers means? Thumb, forefinger or index finger and middle finger, mutually perpendicular to each other. Here mutually perpendicular means see that thumb is perpendicular to forefinger is perpendicular to thumb, and forefinger perpendicular to index finger, middle finger, or middle finger perpendicular to index finger. See that, if you see like that, each finger is perpendicular. When you stitch like that, next we want to find that the direction of each finger. So I will write first what are the fingers. First one I will write index finger. Second one, thumb finger. Third finger, middle finger. So these fingers indicate, each finger indicates certain direction. Your index finger indicates direction of the magnetic field. Next, thumb finger indicates direction of the motion of the conductor. Middle finger indicates the direction of the induced current. Okay. Next, where we apply the Fleming right hand rule means electric generator. AC or DC. We have to apply the Fleming right hand rule and find the direction of the magnetic field, direction of the motion of the conductor, and direction of the induced current. Identify where we have to apply and identify means the AC generator or DC generator we will apply, find the directions. Next, I already told we will recall Fleming right hand rule or left hand rule also. So see that Fleming, next time Fleming already we have discussed. So no problem, I will recall once again Fleming left hand rule. It is nothing but same for right hand, but take your left hand, stitch the three fingers mutually perpendicular to each other, thumb, forefinger and middle finger. Each finger indicates certain direction. See that here, forefinger, first here starts to index finger. Next finger is middle, the order will change, and third one here, thumb. So index finger also here also, direction of the magnetic middle finger, direction of the current, and thumb represents direction of the motion of the conductor. So see the board. Fleming right hand rule is there. Fleming left hand rule is there. Fleming right hand rule used in the electric generator AC or DC. Same for the Fleming left hand rule used in the electric motor. Electric motor AC. Electric motor. So what are the main difference means? See, Fleming right hand rule, middle finger indicates direction of the induced current, but Fleming left hand rule, the middle finger indicates direction of the current. Induced means the current is generated, but here they are ordinary current, the direction of the current. This is the big difference for Fleming right hand and left hand rule. Fleming right hand rule, first we are indicate the index, thumb finger and middle finger. But in the left hand rule, index finger first, next second, middle. The order changed in the compared to the right hand rule. This is very important 2 mark question. Maximum number of time this question is asked. Very important. So you will prepare simple way to first right hand rule means stitch the right hand in 3 fingers. Mutually perpendicular to each other. Thumb, index finger or forefinger, middle finger. Left hand rule means stitch the 3 fingers in our left hand, mutually perpendicular. Forefinger, middle finger, thumb. Okay, got it. So any doubt for Fleming right hand and left hand rule? I hope there is no doubt. If you have any doubt, please ask. So next our topic is motional EMF from Lorentz force. What is the topic? Important 5 mark and 3 mark or 3 mark question. Motional EMF from Lorentz force. What force? Lorentz force. We already discussed Lorentz force in our previous chapter 3. EMF also we are already revised, discussed chapter 2, current electricity, and in this topic also we discussed induced EMF. That means in this chapter. Now we are going to discuss motional EMF from Lorentz force. Okay. So shall we start? I'll take uniform magnetic field. See that? I'll indicate in cross. Uniform magnetic field. The uniform magnetic field, how that means perpendicular to the plane of the paper. Suppose here at the board we can't able to see the paper. If I will draw the diagram, another diagram, see that this is we will consider paper. When the magnetic field move and crossing through the paper, this is into the paper, out to the paper. What is this? Magnetic field. B means magnetic field. Here the paper is perpendicular to the magnetic field, or magnetic field is perpendicular to the plane of the paper. That I indicated here in the board. Cross. Cross means the magnetic field. What is that? The symbol cross indicate, what they indicate means magnetic field. This is the symbol of perpendicular, write in words, otherwise use in the symbol perpendicular to the plane of the paper. Okay. Next, I will take a rod or conductor. Here I will take the rod or conductor C. A, B, what is here AB represent means is nothing but conductor or rod. What is AB here? Rod. Next is the rod of length is or conductor of length is L. What is here L denotes or indicating? The L means here L indicate the length of the rod. Okay, any doubt? So I'll take uniform magnetic field. The uniform magnetic field represented by B vector. That is represented by cross. That means the magnetic field is perpendicular to the plane of the paper. We can't able to identify because this is board. We can't assume this board is not a paper. Okay. Suppose if you use the paper, I draw another diagram. See that when the magnetic field enter into the paper and move on to the paper, the magnetic field is perpendicular to the plane of the paper, or paper is perpendicular to the magnetic field. Okay. Next, we have to use one take conducting rod or conductor. That we have to assume the two ends are AB and L is the length of the rod. Next, we have to move the rod with the constant velocity V toward right to the magnetic field. See that? I'll show. When the rod AB move toward right to the magnetic field. See that? Right side of the magnetic field. Now the new position of the rod. I'll show that. Because we have moved with a certain velocity B A. Here we are moved no rod. Not only rod move, in the free electrons in the rod also moving. See that? I will show that free electron in the dot points. Because rod made by atoms. Atom means it is nothing but proton, neutron and electron. Here free electrons. These free electrons are not only rod moving, free electrons also moving. Due to the motion of free electrons, what happened means where they are moving means the free electron move in the direction of B to A. So next point, free electrons. This means what is this indicating? This indicates electrons. The free electrons move from B to A in the rod. So due to the free electrons move B to A, they are generate the magnetic Lorentz force. What force? Magnetic Lorentz force. Already we have discussed magnetic Lorentz force in our previous chapter, so no need to explain. So magnetic Lorentz force, that magnetic Lorentz force represented by the symbol FB. B means magnetic field, F means magnetic Lorentz force is nothing but minus E. Here minus E indicate, actually E means electron, my negative sign indicate charge of the electron into B vector into B vector. Here what is V and what is B means? V is the velocity of the moving rod. B means magnetic field, uniform magnetic field. E means minus, E means is nothing but charge of the free electrons. Always the electrons are free. What is the charge mean? We have to consider this is equation number 1. This is equation number 1. Just a minute. Due to the action of Lorentz force, what is that? The action of Lorentz, right? Due to the Lorentz force to accumulate. What that accumulate means? Free number of free electrons more in the end A. See, I will show that already free electron is moved from B to A due to the motion of conductor. Due to the action of what force? see that Lorentz force, they accumulate number of free electrons at the end A. See, like that the free electrons accumulate in the conductor and move from B to A. Already moved in the end A. So due to the accumulation of free electron at end A, automatically electric field is set up. Sorry, potential difference between the end A and end B. Where is that? Potential difference set up to the rod ends to the rod where to where means A and B. In the end A, negative charge, in end B, positive charge. Due to the potential difference between end A and B, automatically the electric field is established. Due to the establishment of electric field, what happened means they generate another force. What force means electric Coulomb force. Due to the Coulomb force, they produce. We can write the equation F E. See the equation number 1. B F means magnetic field, Lorentz force. Electric field, what force this? Coulomb force. Equal to E. This is consider equation number 2. When the excess electrons or the free electrons accumulate more at the end A, as soon as the electric field increases continuously. How long it continues means as long as the excess electrons, free electrons end A available, the electric field continuously increases. That time what happened means the electric field reach the equilibrium point. What point? Equilibrium point. So after the equilibrium point, no more electric field increases. So that time the Coulomb force and Lorentz force will be equal magnitudely. So it attained the, what means it attained the equilibrium position. Electric field reach the equilibrium point. Coulomb force magnitudely, Coulomb force, sorry, magnetic Lorentz force magnitudely equal to electric Coulomb force. F. Consider this is equation number 3. Okay, got it. So just we recall once again what we discussed. Motional EMF from Lorentz force. I'll take uniform magnetic field. The uniform magnetic field is perpendicular plane of the paper. In that uniform magnetic field, I kept at a rod. The rod of length L. What is it? The rod is 2 ends A and B. Now what I want to do means I'll move the rod with the constant velocity right to the magnetic field. Not only when the rod moves, the free electrons in the rod also moves. Due to the action of magnetic Lorentz force, they are given the equation magnetic Lorentz force equation minus E V vector into B vector. The action of Lorentz force accumulate number of free electrons where means at the end A. Due to the more accumulation of free electrons, the rod maintain the potential difference between the end A and B. Due to the potential difference, the rod automatically establish the electric field. Due to the electric field, they create a Coulomb force. Coulomb force equation Fe equal to minus Ee. The electric field reach the equilibrium position. When the electric field reach the equilibrium position means as long as the excess free electrons available in the end A, the electric field also increases. So it attain the, if suppose the excess electrons continuously producing, means after some time the electric field reach the equilibrium point. At the equilibrium point, the Coulomb force and Lorentz force magnitudely equally. That equation I can see here, magnitudely, equation number 3. Now I want to substitute the equation number 1 and 2 in 3. See, substitute equation 1 and 2, where is in equation number 3. Okay. So what is equation number 3? See the board. Coulomb force and electric Lorentz force. Left side of the equation magnetic Lorentz force, right side of the equation electric Coulomb force, isn't it? So in the magnitude level, so see that E V vector cross B vector equal to minus E into capital E, magnitude level. The magnitude, I will write the another form of equation, minus E V vector into B vector, sorry, the ordinary form V sine 90 degree. Why 90 degree means because the magnetic field is perpendicular. That's why. So minus E into E. From this equation, the electric field charge of the electron cancel. So rest of the term VB sine 90, we know that 1. So E. So VB equal to E. This is equation, already we have written 3 equations. So equation number 4. Next step. The potential difference between the plate between the plates, between the ends of the rod AB generate the electric field. So potential difference represented by V. So what is that means? EL. L means length, E means electric field. Why? Because potential difference between the ends of the rod AB, they are established the electric field. How long means the length of the rod. Because the rod length is L and electric field. This is equation number 5. Now substitute equation 5 in equation 4. So equation 5, equation 4, E is equal to V into B. So instead of V, what we will write? So already B is there. Instead of V, I will write EL. What is that? B. Instead of E only. Sorry for the mistake. Instead of E, I want to substitute. What I want to substitute? VB. So here, once again, in this equation, I'll write instead of E, I'll write V. V is equal to instead of what is that? E is nothing but VB, isn't it? So V B L. In this equation, I'll rewrite. So V is equal to B L V. This is equation number 6. Any doubt? This equation number 6. I hope there is no doubt. It is very simple. Instead of V, I'll substitute EL in the equation number 4. The Lorentz force of the free electrons responsible For what means they maintain the potential difference between rod AB, isn't it? Potential difference produced between the rod. So due to that, they produce EMF. This EMF is known as a motional EMF. Got it? So motional EMF from Lorentz force. So the equation number 6, left side V is there, no, that we will write that EMF is nothing but symbol psi equal to BLB. This is equation number 7. This equation number 7 is nothing but our required equation. The EMF is produced by or due to this above EMF produced due to the motion of rod, where means in the given magnetic field. So we call that EMF motional EMF. Just we assume when the rod is connected to certain external circuit. For example, once again the diagram, uniform magnetic field, isn't it? The rod without moving the magnetic field, the length of the rod is L. When the rod moves certain distance right to the magnetic field, B, A, free electrons moves from B to A, and number of free electrons accumulated here. Due to the rod moving, they produce what EMF? Motional EMF. Where they move? In the magnetic field. How means? Towards right to the magnetic field. Suppose the moved rod, we have to connect with the external circuit. The external circuit containing resistance. So what is the current produced in the external circuit? This is the resistance. You can write the equation. What is the equation means? See that equation. I is equal to E by R. Is nothing but Ohm's law. So equation number 8. Now substitute, that means this is not E, actually E or psi. Substitute, now substitute equation 7 in 8. So what will get the equation? See, we will get the new equation, current. So what is that new equation, current? I equal to, what is that numerator? Psi. What is that psi value? BLB by R. This is our required current. This is equation number 7, required motional EMF equation. Equation 8, required current. Okay, this is motional EMF from Lorentz force. That means we are using Lorentz force how to derive the motional EMF. Use this equation number 7. They will give number of problems. How that problems they will give means, they will give the magnetic field. For example, you will solve the problem. I will give the value of magnetic field, length of the conductor, velocity to find the EMF. For homework. So magnetic field is nothing but 10 Tesla, unit of magnetic field Length of the rod 5 meter and not 5 centimeter. And what is the velocity of the rod? Means moving 2 meter per second. This is the value. What you want to find means what is the motional EMF. Suppose the same value, I will give the resistance value 100 ohm to find the current. Okay, so this is the homework. When you come next class, you complete and come that homework. Not only this, you will complete and come in the motional EMF from Lorentz force. This is a repeated 3 mark and 5 mark level question. If you have any doubt, please ask me. Always you will write when you study number of times, you will write and see, then only you will get a clear idea. Without writing, you can't write in the answer in your examination, because physics means very difficult one. You will learn number of time means you will write more number of times. That will help you. Okay.